My name is Dileesh. Welcome to my talk on optimizing network performance and automation using Apache Airflow, Python, and data science. So let's get started. So I'll cover this PPT in brief, and then I'll go through how Apache Airflow works and give a short demo of it. I have it installed on my local machine, so I'll just give a quick demo of it later. So let's get started with the presentation. So, introduction to network performance automation. So, there are several modern challenges that networks face right now, which is due to the increase in complexity and scale of the devices and the new technologies that come into place. So, everything needs to have network, right? So, all of these challenges, some of them can be solved by automation. And the main driver for that automation is Python and the orchestrated platform that's best built for running Python workflows is Apache Airflow. So for network challenges, so there are several components, right? So coming to complexity. So there are several multi-layered architectures with a mix of legacy and modern systems. So there are different devices that we connect to and different protocols that they follow. And there are different technologies that exist within a single network as well. And the network has to support all of these technologies in tandem. So coming to scale, so now due to the proliferation of the internet, so right now the connected devices that we use have exploded in scale. So for example, from your watch to phone, headphones, laptop devices, any IoT devices that you do. And it's growing actually. So the projection is within billions within 2020, 2030. And due to the increase in density as well. So if you take a grid of certain areas and compare the devices that exist right now with a previous version of the devices, so right now the density has increased a lot. And if you want to have a smart city or an industrial IoT city, that it puts really pressure on the current infrastructure and it tests the limits of it. And there are other challenges such as resource allocation, where you have to distribute all the bandwidth to all these devices and the compute power and storage to avoid bottlenecks for the devices. And latency as well. So coming to latency, you would need a network to perform in a very optimized way for these devices to stream whatever content that you are streaming, right? So for example, if you have an AR/VR device that's streaming data, so you don't want to have any lag in the network. So all of these are challenges that are faced by networks currently. So the role of automation in improving network performance, right? So automation is one of the cornerstones for scaling and optimizing network performance. It can do proactive fault management, where it can detect any issues with the network, reroute the traffic through devices and congestions and outages. So you can have some automated scripts run the network and resolve that issue. And there are several Python powered automation tools. So Python has played a big role previously and plays a big role right now within the networks to proactively fault manage for these networks. So you can use Ansible, NetMiko, Napalm. So these are all packages within Python, right? So these are powered by Python. And coming to dynamic scaling and self-healing networks. So whenever we talk about dynamic scaling and self-healing networks, there are software-defined networks, SDNs, and you have your network functional virtualization. So it uses Python as well. And Python scripts drive a lot of network and network performance. So it interacts with different devices, different frameworks, routers, switches, any network devices that you have. And these devices have controllers that support Python. So you can use Python to interact with the devices directly, and they have the built-in libraries that are built that you can leverage to interact with these devices. So coming to some real-world examples, right? Apache Airflow, you can use it to orchestrate your network workflows, including provisioning, monitoring, and scaling, such as SIM provisioning, network speed testing, and semantic similarity. So these are some of the examples that we've used in the past for some of my clients, and it's proven to be very good and very optimized version of provisioning, monitoring, and scaling, and improving the network performance. So coming to Apache Airflow. So what is Apache? Right. So it's an open source framework. It's an orchestration tool. Basically, whatever Python scripts that you have, you define those scripts in a way, they are orchestrated in a way that you can run all of your tasks within Python. And the core component of Apache Airflow is scheduler, where it schedules your Python workflows the way that you mention how you want to run it. So it's built in Python itself. So it's built on top of Python. It uses something called DAGs, so directed acyclic graphs, where you can schedule all your components in an acyclic manner. For example, if you want to run 3 functions, you can define which function to run first, second, and third, and so on and so forth, right? So you want to run third first, second, and then first, you can define it that way, making them dynamic and reusable and scalable. Coming to the key features, right? Dynamic workflow authoring. So you can use Python code to define tasks, the dependencies, and schedules for that. In the configuration section, you can mention how often do you want to run it, just like a cron job, right? So you can write the cron expression for it to run to your liking every once in an hour, once in a day, or however you like, right? So extensibility. It can integrate with other systems. You can have custom operators, hooks. So there are already several built within Apache Airflow. And everything is written in Python as well, where you have custom operators that can interface with Azure or AWS or any other cloud provider or any other system that you would like. Scalability. So it supports distributed systems execution as well. So it has components like Celery, Kubernetes, or local executor that can perform tasks in a scalable manner. So you basically start out with a local executor. So these are backend functionalities, right? So executor is nothing but something that's behind an Apache Airflow framework that runs your workflows. So initially start out with a local executor where you execute these tasks. And if you don't care about the scalability part, you can start with local and then scale out basically. So that's how you make the systems distributed, right? So basically you start out with vertical scaling where you have a single device, single machine, and increase the resources in that machine. And then you scale out to multiple systems as your scale and increases. So monitoring and alert. So it has integration with different platforms such as Slack, email, Microsoft Teams, or Discord, anything, right? So all of these things are built in. So you can use that to alert you. And web UI. So I'll get into this later, but it has a really intuitive, really great way to visualize, manage, and debug workflows. Coming to the benefits of it, right? So it simplifies your Python code a lot. So if you have, let's say, 1,000 lines of code, it's really hard for you to manage and maintain that code, what went wrong, where it went wrong. Of course, you can do some logging statements and find out what's going on. But Apache Airflow gives you a really intuitive web UI where you can log in and check the how your DAG performs and see where it went wrong exactly. So it enhances the transparency, logs, and visualizations. So you can visualize what's going on with your workflow and reduce manual interventions. So use cases of Apache Airflow in network operations, right? So you can have Apache Airflow run SIM provisioning. So it automatic tasks like provisioning physical SIMs or virtual SIMs, managing IMSA ranges, and updating systems like SRP, Gport HSS, FirstNet HSS, and others. And once I've implemented this, it turned out to be a very fast execution of SIM provisioning rather than the legacy systems. So Apache Airflow gave us a platform where we can leverage Python and different parameters of provisioning process to really improve the speeds for FirstNet HSS. FirstNet is nothing but first responder communication network, where all of the communication for first responders happen through that FirstNet HSS, and it turned out to be really great for that use case. Network speed testing. So gathering telemetry data, analyzing key performance indicators, triggers, anomalies in network. So it turned out to be great use case for net speed testing as well. Coming to configuration management, deploying configuration to router switches and other servers and services, it makes it very easy to configure all of your devices within your network, and predictive analytics as well. So the way that you can write Apache Airflow workflow, you can have all of your ETL tasks performed within the pipelines itself. And you can have your machine learning models, semantic search models as well. So how Apache Airflow helps automate workflows, enhance efficiency, and optimize resource use. So coming to automation, right? So Airflow eliminates manual interventions. That's like how automation works basically, right? So you trigger your workflow based on scheduler or the external events. It runs all the tasks that you define it to run, and then picks up all the things that you want it to do. Efficiency. So if you run Celery as an executor in the backend, it can parallelize tasks to how many cores you have in the system. You can have multiple sim requests processed at once and reduce execution time. It reschedules the failed tasks intelligently. So there is already built-in mechanism where you can handle retries, failed processes, and ensure that the workflow is reliable. So resources optimization, right? So there is some concept called task queues where you can manage the balance and workloads within multiple VMs, where you can use Kubernetes executor to scale out all the pods and containerize workflow execution. So you can have your resource allocation as well. So automation workflows for large sim provisioning projects, you can use Airflow that we've discussed earlier. So why use Python for Airflow, right? So Airflow is built on top of Python itself, but within Airflow, you can code Python again. The intuition for using Python is basically easy to learn syntax, extensive libraries, so it has a really good open source, and all of the machine learning and data related stuff happens in Python in nowadays, right? If you want to talk about Spark, and so there is libraries for PySpark within Python itself, where you can use Spark modules and Spark frameworks within Python. And there are several libraries and frameworks that lets you manage all your network automation needs within Python. So NetMiko or Paramiko, if you heard about SSH communication, these are frameworks that help you with SSH-based communication to configure network devices and interface with those. So you can automate tasks like device configuration, backup, troubleshooting. So you have Napalm, PySNMB. You can check this out later. I'll just give a brief overview of Network X is a really good thing where you can analyze and visualize network graphs and topology and mapping and simulation of the networks. Pandas and NumPy for network telemetry and logs, trends, and anomaly detection. Basically, Pandas, you can create data frames and process objects within Python. So predictive analytics for network optimization, right? Role of data science in network optimization. You can identify trends and anomalies in network performance. You can predict failures before they occur, reduce the downtime, and you can optimize the resource allocation such as bandwidth, processing power used for network optimization. So machine learning, right? So there are several libraries built on in Python for machine learning. So if you're trying to build a machine learning model, you don't need to do it from scratch. Python probably has a library that already does that. So scikit-learn. So there are several scikit-learn. There are several libraries within Python for machine learning. You have TensorFlow, PyTorch, Pandas, NumPy for your data processing, and you can use these libraries for some use cases such as failure prediction or anomaly detection. And automation use predictions with Apache Airflow, right? So you can use Python integrates basically with everything, right? So any device, any network device, any models, any third-party systems that has support for APIs, it probably have a built-in library that it can leverage. It enables real-time decision making through triggered events, right? So let's take an example of a workflow diagram, right? So you collect telemetry data, you run a machine learning model for prediction, and some kind of automated action you can trigger with that. So automation of network configuration and provisioning, right? So using Apache Airflow and Python, you can do some complex stuff such as SIM provisioning and network setups. You can set up a script that does provision to systems like HSS, FirstNet, Gport, HLR Mind, and range allocation for SIMs and MCs. Coming to benefits, right? So it's efficient, accurate, scalable, and monitoring wise for Apache Airflow, everything that I mentioned right now, those are the benefits that for using Apache Airflow. If you take an example for SIM provisioning within Apache Airflow, you collect all the user requests, SIM types, MC ranges, and you execute the provisioning tasks to different systems. So each system has its own component where it uses either Telnet, LDAP, or whatever communication, way of communication that you do either SSH to that system and provision all those SIMs. You validate those, you provision the log status, and you can have a workflow that step that can notify someone of the completion. So that's basically it for how to optimize. So let's dive right in to how Apache Airflow works, right? Airflow is open source tool, right? So there is really good documentation on how this basically works. What providers, these are all the active providers that Airflow supports right now. So you can have connection to Cassandra, Amazon, AWS, a lot of stuff basically. So if you take Amazon, for example, using Apache Airflow, they provide all the versions related to within their server itself service. So installing it in your local, right? So I've installed my version using Docker. So there is really good documentation on how to do it. So you can play around with it as well. So first, let's make sure our Docker instance is running right now. So Docker engine is paused. So let's resume that. So I already have Docker installed. Let's go to our terminal. Let's check. It's already running. No, Docker PS. So I've installed earlier. Let's check. So I have the Docker Compose file. So let's do Docker Compose up. So it creates all the containers and it starts up all the services that are required for. So one of the good thing is all of the containers are built in using Docker. So you don't need to create each instance separately. If you're planning to run a parallelized version of Airflow. So it's starting up. Let's see. So it started all the Airflow stuff. Docker, Redis, Postgres. Postgres 13 is the database that Airflow backend uses for storing metadata. So web server looks like all the services running except for Docker Airflow. Let's see what's going on. There you go. I think it started now. Let's go to local version, check if it's running. So I see the instance is running. So this is a UI that you get to. Now you get to login screen, but default or Airflow and Airflow credentials. So here you have your DAGs. DAGs are the workflows that you can schedule to run in Python. And it shows all the DAGs, right? And there are two sections here called active and paused. So you can have your workflow and you can either have it run or in a pause state or an unpaused state. If you want to run it, you can click on this button. It will make it active. So there are two active workflows right now. If you want to turn it off, you can just turn it off using this button. So it gives a really good user interface. You can manage everything here. So coming to security, it has users, roles, actions, everything, permissions too, right? So you can manage user permissions. If you go to users, you can find all the users here. You can create users. You can drill down into how you want to manage the RBAC for users. And you have admin section as well, where you have all your variables, and you can basically create connections to different services where it can see, it has all the stuff related to Amazon, AWS, Azure, Docker, or anything, right? So it has a lot of built-in libraries. You can interface with SQLite database as well. If you select SQLite, it should give you a connection to the SQLite. So you give it a host, login, password, it should be able to connect to, and there is an option to test as well. So you can create a connection and test it out. Coming to workflows, right? So this is an example workflow that I ran earlier. So it gives you a really good interface. So it took 20 seconds to run. The run type is manual because the schedule is none. So there is no schedule setup for this. So if I run this again, so it should automatically trigger a new diagram where if you check the graph of it, how this looks. So this is how the graph looks, right? So first it goes here, the logical output is run this, and you basically, once this is run, you go to this step, and after this executes, you run all of these steps. So now this is done, right? So let's drill down into each of this. So this is nothing but Python code, guys. So basically you define all of your functions here. These are just examples that Airflow provided. So this is a way that you can specify what the tag is about. And this is a function basically print context, right? So this is a task. This is an operator where you can print the context of what's going on within this function. So here there are other functions as well. Let's see what sleep 3 does. So sleep for 3. So this is task sleep for 3. And you can drill down into event log, what happened within the events, details of this, and you can go into each individual log and check what happened there as well. So if you check the logs, so this is nothing but the log for this task. So all of the quarks here, you have context variables, so you have what happened within the log, within the operator. And if you click on here, you can check out what's going on here as well. So that is it for Apache Airflow. So there is interactive APIs as well. So everything is built in within here. So let's open Swagger. So it automatically takes basic auth flow and Airflow, and you can use this APIs externally as well. If you have Postman, if you want to test it out, you can basically take this endpoint localhost 8080 and run the DAG ID. So it asks for basically few things, right? DAG ID. So you can select any DAG ID. From here, let's check what the DAG ID is for this. DAG ID is example Python operator, right? So let's copy this and paste it here. Oh, let's do get. So it gives you all the information about this, right? So what the DAG is about, the file token, where it is, and what's going on with the DAG. So there is a lot of stuff that I want to cover, but I don't think I can cover it in one session. But you can go to the documentation and find out about Apache Airflow more. So you can run, so this is basically what I told, right? You can run your workflows as code, and security is built within Airflow as well, where there is something called Fernet key that encrypts all your passwords, usernames, everything, right? So basically security is baked in to Apache Airflow. And this is how you set up a DAG, right? So this is basically how a DAG runs. So you define a task, you'll give an operator, and you'll ask Airflow to run the operator. So that is pretty much it for Apache Airflow, Python, and network automation and data science. So if you have any more questions, you can certainly reach out to me. Thanks for joining me in this session.